This is the second block of topic 22. In this lesson, we're going to be using proportional relationships to develop the formula for arc length and the formula for a radian measure of an angle that's related to a circle. So radians are new for us and arc length is also. So those are the two main concepts we're going to be looking at in this block. So the opening exercise here is talking about three friends who are ordering from a local pizza joint, and it says the size of the pizza in names is large, giant, and piggy, and then the size in inches is given. Now the size in inches is referring to the length across the pizza, which we know is called the diameter. So anytime you're at a pizza place, like maybe Brick Oven, and you're ordering a 10-inch pizza, that's what that means. The diameter is 10 inches. It tells us the price that's given here for the large, giant, and piggy pizzas includes tax. And so they gather their money together and they come up with $50. And they notice that there's several different combinations of pizzas that they would be able to afford for that $50. For example, since the large pizza is $15.99, they could get 3 of those, because $15.99 is 1 cent away from 16, and 16 times 3 is 48. So they could get 3 large. But they could also get 2 giant pizzas. That would also be about $48. They wouldn't be able to, however, get 2 piggies, but they could get 1 piggy and a large, for instance. So there's several different combinations of pizzas they could get. What geometric term do we use to represent the crust? So remember, the crust is what goes around the outside of the pizza. So hopefully you know we call that the circumference. That's what we call the perimeter of a circle, is the circumference. So our question is, what if you were only interested in the crust on a single slice? How would that crust be related to the crust of the entire pizza? Well, a single slice would be a fractional part of the entire circumference. So let's look at question 1 in your notes. It is asking us to drag the tiles to determine the circumference of each pizza. So remember, the piggy pizza has a diameter of 24 inches. The large pizza has a diameter of 12 inches. And we know the formula for circumference is simply pi times diameter. So we just multiply these numbers times pi. So hopefully you see that the piggy pizza would have a circumference of 24 pi inches. Circumference is a linear measurement, so we don't put squared or cubed or anything on that inches. It's linear. And the circumference of the large pizza would just be 12 times pi inches. 12 pi inches. So we can check our answer. And of course, it's going to log out, but that's okay. We know it's right. Let's look at the ratio among their circumferences. So it tells us the diameters of the pizzas have a ratio of 1 to 2, and we can see that 12 over 24 is 1/2. Well, if we look at their circumferences, we also get that same ratio, 12 pi inches over 24 pi inches. The pi's would cancel, and 12 over 24 reduces to 1/2. So we would get the same ratio as we did with the diameters. And the reason for that is both of those are linear measurements. The diameter is a linear measurement, circumference is a linear measurement. So of course their ratios are going to be exactly the same. Let's look at questions 2 and 3 in your notes. We're looking at the large and piggy again, the 12 and the 24 inches. It says, by computing the circumference of each pizza, we can now see that 2 large pizzas have the same amount of crust as a single piggy. So if we took 2 of the circumferences of the large, 12 pi plus 12 pi is 24 pi, and that's the same as the circumference of the piggy. Now both pizzas are cut into 8 slices, so we want to compare the amount of crust on one slice of each one of these pizzas. So how does the crust on one slice of pizza compare to the entire crust on that pizza? Since the pizza is cut into 8 pieces, we know that each slice would be 1/8 of the crust of the entire pizza, so 1/8 of that circumference. So that is question 2. How does the crust on one slice of each pizza compare to the entire crust on that pizza? It is 1/8 of the entire crust. If it was 6 pizzas, it would be 1/6 of the entire crust. So we're asked to find the amount of crust on one slice from each pizza. So remember, we've already calculated the circumference of each. So now all we need to do is find 1/8 of those, and we know the amount of crust on one slice of a pizza. So for the piggy, we're finding 1/8 of 24 pi inches, if I could write, sorry. So we know that 8 goes into 24 3 times. So each slice would have 3 pi inches of crust on it. For the large, we're taking 1/8 of the 12 pi inches. And 4 goes into both 8 and 12. It goes into 8 2 times and 12 3 times. So we get 3 halves pi inches, or we can write that as 3 pi over 2 inches. That is the amount of crust on the large. So we can see those answers there. They wrote 3 pi over 2 as 1.5 inches, 1.5 pi inches, I should say, which is fine since 3 halves is a terminating decimal as 1.5. So how is arc length different than arc measure? What we just found was arc length, the length of that arc. So remember, arc measure is measured in degrees. When we find the arc measure, we know it is equal in degrees to its central angle that corresponds to it. But arc length is a portion of the circumference. So it's always going to have the same linear unit that your circumference does. So if your circumference is in inches, your arc length will be in inches. So don't confuse the different things of arc measure and arc length. Arc measure is degrees. Arc length is the linear unit. So to find the amount of crust on one pizza, we just found a portion of the circumference. So a fraction of the circumference of a circle is what we call arc length. So anytime you're asked to find an arc's length, that's all it's asking you to do, to find that fraction of the circumference. So while arcs are measured in degrees, again, arc lengths are always measured in units of length, like inches, feet, miles, kilometers. To calculate an arc length, you just need to know what fraction of the circle the arc is. So in our example, each pizza was 1/8 of that circumference since it was cut into 8 pieces. Sometimes you are not given the fraction of the circumference, but instead you're given the degree measurement of the arc. Well, if you're given the degree measure of the arc, you can figure out the fractional part of the pizza or circle that you're looking at. And that's because we know how many total degrees the circle has, and that's 360 degrees. So your arc measure would just be put as a fraction over 360, and that will tell you the fractional part of the pizza your arc length represents. So let's look at question 5 in our notes. It says the owner of the pizza place knows that his customers enjoy the freedom of buying the pizza by the slice as well as the whole pizza. So he invented this special pizza plate that will help him calculate the different size slices of his pizza. So remember, back to the slice of pizza we were looking at, it was 1/8 of the entire pizza since it was 8 slices. So what was the measure of the central angle of this slice of pizza? Well, since we know the fractional part and we know an entire pizza or entire circle is 360 degrees, all we need to do is find 1/8 of 360 degrees. So when we find 1/8 of 360, then we find that that is simply 45 degrees. So that's the amount of the central angle of his slice of pizza. Question 6 says that he wants to know the amount of crust on a 60-degree slice of a giant pizza. So remember, the giant pizza was the one that had a diameter of 18 inches. So what fraction of the pizza is the slice? So we are looking at the 60 degrees as figuring out our fractional part. The whole circle is 360 degrees, so our fractional part would be 60 over 360, which reduces to 1/6. So that is question 6. Part of it, 60 degrees out of 360 degrees, simplifies to 1/6. That's our fraction. So how much crust is on the slice? So remember, that's going to be how much of the total crust of the whole pizza, which is the circumference of the pizza. We already found the circumference, or actually we didn't for the giant, but what would it be if the diameter is 18 inches? We know the circumference would be 18 pi. It's just pi times diameter, so 18 pi inches is the circumference. So we want 1/6 of that, of the 18 pi inches, and 6 goes into 18 3 times. So that's 3 pi inches is what that amount of crust is. And that is the arc length, right? So remember, that's the same amount that was in the piggy pizza, in the 45-degree slice of the piggy that we found back in number 3. So they have the same amount of crust for each slice. Let's look at question 7. We're going to generalize the formula for finding arc length. So remember, it's just a fractional part of the circumference. So your fractional part can be found by putting your arc measure of your piece of the circle over the total amount of that circle, which is 360 degrees. So that gives you your fractional part. And remember, it's fractional part of the circumference. So which one of these is circumference? Remember, pi r squared is area. We want pi times diameter. So that is our formula for finding the arc length of a circle. That's what you're putting in question 7. So it's just your arc measure over 360 degrees times the circumference, which is pi times diameter. So fractional part of the circumference. In our overview of this topic, we saw that rolling 3 different circles along a line resulted in 3 triangles that were similar to each other. So remember, when we have these similar triangles, we're creating proportional parts. And so the similar triangles created from the rolling circles also show that the circles are similar to each other because their diameters are those proportional parts. So you can think of them as dilations of one another. They're enlargements or reductions of the same shape. Let's look at question 8 in our notes. It says the similarity between all circles is what makes the relationships between their various parts proportional. The proportional relationship between circumference and diameter for all circles can be expressed algebraically as the formula, circumference equals pi times diameter, or by dividing both sides by the diameter, we get circumference over diameter is equal to pi. Remember, pi is a constant. It's not a variable. It doesn't change. It is always the same number, and when you look at the ratio of circumference to diameter, you get that same value every single time. 3.14159, blah, 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 goes on forever. So let's drag the tiles here to express the proportional relationship between circumference and radius. So we're rewriting the formula for circumference using radius instead of diameter. So C equals pi times diameter. Diameter is simply twice the radius. So here's the 2 right here. So we need an R here. 2 times R is the same thing as diameter. So we could divide both sides by the radius and write that as the circumference to the radius ratio is equal to 2 pi. That's just dividing both sides of this formula by R. So this is another formula for circumference. It's the same as pi times diameter. We're just replacing diameter with 2 times the radius because those are equivalent. So that is on your notes here on number 8. So circumference is 2 pi r or in other words, the circumference divided by the radius is equal to 2 pi.